Okay, let's talk about a secret language, a code that's written into almost everything around us, from the food we eat to the blood in our veins. It's called pH, and once you learn to read it, you're going to see it absolutely everywhere.
So, to crack this code, we're going to start with a really surprising mystery. A puzzle about water that, believe it or not, unlocked this whole field of chemistry. Think about this for a second. It seems weird, right? I mean, water is water. So why on earth would a puddle of rainwater conduct electricity when a beaker of super pure distilled water won't? The answer is the key to our entire story today. Well, it turns out the secret isn't in the water itself, it's what's mixed into it. Distilled water is just pure H2O. There's nothing in there to carry an electrical current, no charged particles or ions. But rainwater, as it falls through the sky, it picks up carbon dioxide from the air. That CO2 dissolves and creates a tiny bit of carbonic acid. And that acid releases ions, which act like little electricity carriers.
And there it is. The answer is acid. That shocking discovery wasn't really about water at all. It was about realizing that everyday rainwater is actually a little bit acidic. And that brings us to the tool we use to measure this stuff. So now that we know acid is our key player, how do we actually measure it? Well, scientists have this universal measuring stick they use for both acids and their chemical opposites, which are called bases. And here it is, the pH scale. It's a simple scale from 0 to 14, and its whole job is to tell you how acidic or how basic something is when it's dissolved in water. The name itself is kind of cool. pH literally stands for the power of hydrogen, because it's all about how many hydrogen ions are floating around in a solution. The scale is pretty easy to read. Anything below a 7 is an acid. Anything above a 7 is a base. And right there in the middle, a perfect 7, is neutral. But here's the part that really matters. This scale is logarithmic. That means something with a pH of 3 isn't just a little more acidic than a 4, it's 10 times more acidic. Every single number you go down is a tenfold jump in strength. Wild, right? So let's put some real-world stuff on this scale. Way down at the super acidic end, you've got things like hydrochloric acid. Then come the things we know and love, like lime juice and vinegar. Pure water is our neutral 7. And then on the other side, our own blood is slightly basic, around 7.4. And things we use to fight acid, like baking soda or milk of magnesia, are even higher up. So, what happens when these opposites actually meet? It's kind of like a chemical tug-of-war called neutralization. You mix an acid with a base, and they basically cancel each other out. And what are you left with? Two very neutral things, a salt and plain old water. Check this out. If you take a really strong acid, like hydrochloric acid, and you mix it with a really strong base, like sodium hydroxide, you don't get some crazy explosion. Nope. You get sodium chloride, which you know as table salt, and water. That's it. The acid and base have perfectly balanced each other out. Now, this whole balancing act isn't just some neat trick you do in a chemistry lab. It is happening inside of you right this second, and it is absolutely essential for keeping you alive. Get this, your blood has to stay within this incredibly tiny pH window of 7.35 to 7.45. It's a constant, frantic balancing act. If your blood's pH strays even a little bit outside that range, crucial things in your body just stop working. It really shows you how delicate this whole system is. You've definitely felt this one before. Your stomach produces super strong acid to break down your food. But when it goes a little overboard and makes too much, you get that awful, burning feeling of indigestion. And what's the fix? You take an antacid, which is just a mild base. You're literally performing a neutralization reaction right there in your stomach. The exact same fight is happening in your mouth. You see, when bacteria munch on leftover food on your teeth, they produce acid as waste. If the pH in your mouth drops too low, below about 5.5, that acid starts to eat away at your tooth enamel. And that is, quite literally, how a cavity starts. So what's our defense in this constant acid attack? You guessed it, a base. Toothpaste is designed to be basic for this exact reason. It neutralizes the acid from the bacteria and helps protect your enamel. It's just simple, brilliant chemistry. Okay, so this acid-base battle isn't just an inside our bodies thing. These same chemical rules are shaping entire ecosystems and are even used as weapons out in the wild. Hey, remember our shocking mystery from the very beginning? Rainwater is naturally a little acidic, but when pollution from things like factories and cars causes its pH to drop below 5.6, we get what's called acid rain. And that can do serious damage to forests, lakes, and even stone buildings. And it's just as important in the ground beneath our feet. A soil's pH level controls which nutrients plants can absorb. This is why farmers are constantly testing their soil. They have to know the pH to choose the right crops that will actually grow and thrive there. Even cooler, nature has turned this chemistry into literal weapons. Ever wonder why a bee sting burns so much? Or a run-in with a stinging nettle plant? That's because they are injecting acid directly into your skin. It's a super effective defense mechanism, all powered by pH. So, we've gone from rainwater to your stomach to bee stings. After seeing pH at work all over the place, what's the really important thing to take away from all this? Well, first, just realize you are surrounded by acids every day, and they're not all bad. The tartness in vinegar is acetic acid, that sour pucker from a lemon is citric acid, and the tangy flavor in yogurt, that's lactic acid. They're a huge part of the foods we eat. But the real takeaway is this. So much of life, from the tiniest scale inside your cells to the massive scale of a forest, is one constant delicate balancing act between acids and bases. And the pH scale? That's the language that lets us finally understand it. And if you think that's wild, this whole thing isn't even just an earthbound concept. The same chemistry applies across the solar system. I mean, the atmosphere of Venus is basically made of thick, swirling clouds of super corrosive sulfuric acid. Talk about an extreme environment. So, we'll leave you with a final thought. Now that you know the code, now that you have the decoder ring for this secret language, where else are you going to start seeing the power of pH at work in your world?